Hello, welcome. Today, we are going to talk about TypeScript. Are you using TypeScript correctly? Are you really using it to its full potential? That's what we are going to go through today. And I have 3 topics in mind. First, go over the basic types and talk about the soundness of type and how you should think about TypeScript. And then we go to the next level, talk about type inference. And then after that, we'll talk a little bit about type level programming. So the type level programming, I'm just going to touch on it a little bit because it's a pretty deep topic. And in the future, I will have other videos to talk about it, say, for example, using examples in TypePress. But for this one, it's just what you're going to learn, or what I'm going to talk about, is how do you approach, right? How do you approach your TypeScript and what you should and should not do. And I'll be using an example in Moctometer, which is I find out today that there's a little bug over there, and that's why we'll talk about this. So without further ado, let's get started. So first things, talk about types, right? When you're using TypeScript, I assume you would, well, the level 0 is you use TypeScript, but you don't use any types. I hope none of you will be doing that, because if not, why are you doing TypeScript to begin with, right? And so when you're using types, right, you try to declare types of your, say, for example, you have a function, right? Let me make it a little bit bigger. So a function foo, right? So you can assume, let's say, do an add, right? A, you will say it is a number, B is a number, and then you say it returns a number, right? And then you just say return A plus B, right? That's it. Right, so that is the basic usage of TypeScript, right? You declare the type of your param and declare the type of your return value, and that's it. So it's easy and it's basic stuff, but the problem is that you need to remember that TypeScript is a language only exists before compilation, right? At the end, what's run on the browser or even on the node, unless you're using TS Node or something like that, is just JavaScript, right? So the type that you put in, it does not exist at runtime. Right. So the problem with this approach is that the type you define over here might not be the correct type, right? So for a simple example like this, that's okay, that's fine, right? But when it gets more complicated, it's hard to get the right type, and sometimes you might declare the type to be too aggressive. I put it this way, and say recently I just saw a videos talk about solid principles with TypeScript, and it is a decent videos, but there is a quite a few concepts over there I think can be improved a little bit in terms of how it's getting presented and described. So one of the issue over here is that in, say, interface segregation, right? The type that you need, right? Say, for example, what the hell I'm doing? So say, for example, I have a function over here, and let's say this is something that I was just working on, so I'm just using it as an example, right? So over here, well, let's say request, and then you take a config, and it is a axial request config, right, like that. It is a generic type, but we let's forget about that in this example. And then request, and then pass in the config, right? Say, for example, like that, and then you do something else over here. And so the type over here, this is fine. But what if what you are doing inside is, for example, this is a post, right? For example, so this is a post, and in here you're going to use the post and put in some config over here. So the problem with this is that inside this axial request config type, there is a property called method, right? So the method is a string, right? Actually it's an optional string, right? It's a string or union or undefined. So the problem is with this function, right? You are already doing a post, so the method property over there doesn't really make sense, and in fact you actually don't want people to put it in, even if it is a optional type, because when someone's using your code, say using a post and then put in try to fill in the config over here, then when it autocomplete, because of the type, the axial request config have that type, right? Have that property, so the completion will or the code will allow you to put in a method. But if you do this, right, if someone do this, what does that mean? It completely doesn't make sense, right? So that is the interface segregation, and you should use only the thing that you need. Say, for example, in this case, you would actually doing something like omit and method, right? So that the config that get passed in, this will be invalid. Okay, so that's that. So, but this is just a pretty simple example, and that's how the level 1 way you can use the type in TypeScript. And the other things you need to be aware of is about the soundness of TypeScript. So the language TypeScript itself is in its design goal, soundness is not one of the priority. Right. Of course, soundness is important, and for those who don't know what soundness means, is basically a thing about accuracy. Is it correct, or does it make sense, right, to put it in layman's term? And so TypeScript is not designed for that. You will encounter cases that it doesn't work. It doesn't work at all, and no matter how you do it. So in this video, I'm not going to go too deep into the soundness. That just talking by itself is another 2-3 hours worth of material. So I'll just skim over it. And for this video, in this topic, I'm talking about because you need to know, you need to understand that TypeScript, the language itself, is not necessarily sound all the time by default. So do not take the type too seriously. I'm not saying that you should just completely ignore it and always do things whenever you're happy, just put any over there, right? But then that's, you just do yourself disservice, right? What's the point for using TypeScript, right? But at the same time, sometimes you will need to do that, right? Because sometimes it's just There's no way out. You couldn't get it to work. And so don't, my suggestion is don't fuss too much, right? Of course, you need to learn about TypeScript and be cautious when you are casting something to any. You need to know what you're doing. But at the same time, when you do that, you should confidently tell yourself that, yeah, there's not much you can do. Let's cast it to any. Right, so and that sometimes is okay. So just want to point that out in terms of the soundness. Then the next level of using types is using type inference, right? So in say using a function again over here and get it back to what it was, say like this. Let's simplify it like that. Over here, further, can I do more? Yeah. No. So let's say do it like this, right? And then you might want to say promise return something, right? Type this out. So the type inference is meaning instead of doing this, right, relies on the type that the code that you're writing, they probably that the code that you are using, they probably already have types built in, and they would return the right thing, so you don't have to set the type yourself, right? And then it should able to do it, and that will help making your code cleaner. You don't have to do all these type diligently. It will just work, and say when you need to refactor the code, you don't have to change all the type, and that's really just slow you down, right? That's one of the criticism people might get when they don't like TypeScript. Say, that's too much work. And yeah, because of that, I can do much faster without TypeScript. I just write it in JavaScript, right? Yes, in sometimes, right, without the type, yes, you can write things faster. But if you really care about your quality, and especially you're not writing tests, and I'm not suggesting you to do so, you should definitely write tests. And then you would just asking for trouble down the road, right? Because things will happen, right? Put it lightly. So use type inference. That's the second thing, and a lot of time people might stop there, right? The third thing, the third level, is start getting into type level programming. So what I mean is that yes, type inference is fine, but it has its limitation. The limitation mainly is because you need to understand type is a higher level concept than the actual code. So here I'm talking a little bit about functional programming and category theory. So think about the type is a higher level or higher order level concept, right? And those types dictates what you have, how the code should behave, how the actual code, the JavaScript code should behave. And the fact that, again, TypeScript is just a JavaScript, is a superset of JavaScript with type system. They are disconnected by default, right? That's how it is by default. And because JavaScript is very flexible, it doesn't have the those type system to begin with, although I should say that JavaScript still have types, right? You have object, you have string, you have things, so on. So it's not really a typeless language, but it's definitely have its limitation, right? And or have its flexibility because of that. And it is very difficult for TypeScript to able to simulate all the behaviors that you can do in JavaScript, and that's also one of the reasons why TypeScript start with soundness is not a high priority thing, right? Again, it's not important, but it's just comparatively to other things, sometimes it will break here and there. So with that in mind, now we can get to the example. Okay, and again, the type inference stuff here, I'm going to show you a little bit of that, and also since I don't want to get the videos too long, so won't get into too deep detail. But just showing you how it works. So for example, over here, what you're seeing is this create zucchini. This is some code in Automata, and I'll cover that in the future. So you can see that here I describe the type of the input param, but the output param is not declared, right? It's just completely rely on the whatever that get returned. So say for example, this scenario, it return it have this type, right? And then this define step have that type, and then this define parameter type have that type. So the create zucchini code, when it's get called, it will have those type inferred, so you don't have to type it yourself. And you can see that this, if you have to type it yourself, it can get complicated, right? And the same thing goes downwards, right? It drills down. The same thing, you can see that over here there's no types, right? And because and even over here, the only type that I have is a cast, because just the empty array, TypeScript doesn't know what kind of array it is, so you have to add the type over there. And so here, then it will infer the type, and you don't have to do much. So, and the same thing over here, go to the create scenarios, and then in this functions, and then down in this function, it returning this object with this ensure setup and spec code, and so on, right? So that's that. The problem that I encounter over here is that, say, this spec function, right? This spec function, say, take a look at this code. The spec function is for simulating some behavior, and so in this case, it's simulating a function, a async function. So you can see that the type, this is shows the type of the function. The subject is a function is with no params and return a promise, and the promise of any. And then if you look at the S, you can see that the S or the spec subject in return is exactly that type. So this is working fine. However, if I go further down over here, let's see, yeah, say over here like this. Here, this also is a spec function, but the type is being messed up, and so you can see that here the subject is any. It doesn't have the type inference, and so the spec subject is also of type any. And so that is the problem. I should expect that the is type equals true, and in this case it should be x as a number, and then this return a number, right? So type of f of s. And this also over here, this is one problem. Yeah, let me change this to true. Can assign as So now you can see that this failed, right? If I say it to false, yeah, that's fine, right? And this, so so you can see that this failed. And so the reason for that is because I was relying on the type inference. You can see that over here it goes directly to here, and this spec object is created in this function, right? This create spec function. The detail you don't have to worry too much about it, and you just need to know that these functions return this several functions, and the code over here can use it. So that tie back to the higher order nature of the types, because when you're using type inference, you are inferring the type from the specific instance of the type, right? So if you think about the order between, or the relationship between type and the runtime, the code, you can map that kind of like the relationship between class and instance. So you create a class full, and then you create an instance full, and the instance full is an instance of the type class, right? So if I say, make sure that it's clear for you. So say I create a class full, and then I have a do function, and then return empty string, right? And then const full equals the new full, right? And then so full dot, you can have the do functions, right? And that's fine, right? That's work, and that return is string, right? However, inside the class, say for example, you can have a static function, right? Static eat. I don't know what foo wants to eat, but let's say doing that. And of course, the foo function, the foo instance over here will not have access to that eat function. And the same thing is that, say for example, this is type of t, and then let's say this extends. I'm just really creating this on top of my head right now, just runtime doing stuff. So let's see, let's say array of any, right? And then let's say get, right? And then this will return this dot array, right? Say for example, and then say private array, like that. Right, so when I calling this, this will be the type never, because we haven't defined anything. And as we can of course do it like this, then this will getting this any type, right? And it will not able to get back the type t, the generic type t, right? So that is an example to show you that what you get when you're doing type inference is only the instance. So over here, the type, what you can do is can only be any, or say if you say want this to be a string array, right? The type t is string array, then this will be a string array, right? It cannot be any other thing which the class itself support. So it's the same thing at the type level, that when you're using type inference, you won't able to get the next higher level stuff, right? In this case, at the type level is about the generics. So the issue that you're seeing here is exactly that, right? Because I have created the spec function over here, and this is already an instance without all those specification or the ability to say, oh, this is actually a generic type, it accepts some generic type, then this won't work, right? This will always just get any. Right, so because what we can do is change this to the cast it. Well, so let's actually put it this way. Let's see what can we do. Right. So you will see some of the weird thing in TypeScript. So what we want over here, let's see, where is the type step mode over here, right? What we really want is just this, right? This is the type that we want it to be, and there is, I have some existing type over here and there, but I can't, you know, for simplicity for this video, I'm not going to look it up and do that. So you can see that I cannot do this, right? And how about I try to cast it? How can you cast this, right? How can you assert this type to be something that accept a generic type, right? So let's see. Right, just have fun with it and see if we can get that, right? So what is S? S will get that, right? And this, if we say this as S, right, then the spec, this will get that guy, and then we over here, then now this will work, right? So actually, it's a surprise to me that we can do this, but you can see that this is horrible, this crazy stuff, and you would, you know, try to do this directly in here, and I think you can't. Well, let's see if we can S that. Can we do that? So that we can skip that. Yep, we can do that. We can do it like that. So yeah, so that would fix the issue. But you can see that you need to do something special. And then this is actually, you would need to be very careful about this, because for this case, this is exactly what I wanted to do. But in a lot of other cases, when you are working on your code, this might not be what you want, right? Because say, for example, you're thinking about a class or a type, a overall type of the things that you're working on, you typically would define the generic type at the overall type level, not at a particular function level. So, and that, so if you are doing that, and if you're expecting that and doing this right here, is you're probably doing something wrong. But in this case, that is exactly what I need to do. Right, I do need to use the spec to say, okay, this is just they would accept a generic type, and so that this will now work correctly. And so when you were doing this assertion, you can also see that there is that separation between the actual runtime versus the type that you are handling, because the type is more flexible than the actual, well, actually, should I say it's more flexible? It should be other way around, right? Well, it's a kind of like sandwich. So the actual runtime or the actual runtime is flexible, right? The actual runtime, it doesn't really care what type it is, because in JavaScript it doesn't have this kind of type. And then there is the inferred type of the code from produced by the TypeScript compiler, or in this case, the TypeScript language server. And this is a much more restrictive type than what you want. And then what we want to do is expand that a little bit by saying, hey, this code, it is not that restrictive. It can actually do a little bit more, right? So you can give it a little bit more freedom. But you can see that when you give it a little bit more freedom, you, as the one who write the code, need to absolutely understand what you're doing. You're not overextending what the code actually capable of doing, right? And the TypeScript, when you're using type assertion like this, you are telling TypeScript to saying, hey, I know that you think the type of this function or this code is X, like this, but I assure you that it's actually capable, or it can do things like this, right? So you are telling the TypeScript compiler and overriding and saying, okay, yes, thank you. This I know what I'm doing. Trust me, right? And in order as you're telling the TypeScript to trust you, you have to trust yourself too, right? You have to have the ability to have the confidence to trust yourself, knowing what you do is correct, right? So, yeah, so that's it. And again, they're saying the type level programming is a lot more complex than what I'm just showing here. There is a lot of things that you can do. And I will, in the future, talk about it a little bit more. So with that, that will be it for this videos. Hope you enjoy this and hope you learned something. And with that, see you in the next one. Bye.